Hey Geometry, we are in Unit 6, Lesson 11, kind of the home stretch. So let's do a little bit of review on transformations. Sort of a nice break after the few lessons we had on parabola, geometry, distance formula stuff, right? So here we're going to apply the transformation rule. Xy goes to negative y comma x in the quadrilateral. What is the effect of the transformation rule? So let's go ahead and practice. For point A, x and y are 0. So to do the transformation, we don't do anything. D, I have 5 comma 2. So I'm going to make it negative 2 comma 5. And then 6 comma 0, so it's going to be 0 comma 6. And then 5 comma negative 2, so it's going to be positive 2 comma 5. And that stays A. So what did we end up doing here? It looks like we rotated it. Looks like we rotated it 90 degrees in a counterclockwise rotation, right? And I guess it's the origin is the center, I should say. Origin, the center is the origin. Okay, if we look here, this is what we're doing. All right, I'm gonna get my highlighter out. I've drawn, well, the book has drawn nice, neat, perpendicular lines. That right there is the perpendicular symbol, right? So perpendicular lines. Now if we notice, those perpendicular lines are segment AD and segment AD prime is where these perpendicular lines come from, right there and right there. That's an awesome line, isn't it? Well, not much better. I'm going to erase them anyway. So to summarize, that 90-degree rotation means that the original and the image lines intersect at 90-degree angles, which means the lines are perpendicular. That's the perpendicular sign if you remember it from long ago. So let's see what we can do with this. It says make a conjecture. Complete the table with the slope and with the slope of each segment from the warm-up. All right, so you have to go back to that warm-up and count your slope. So if I look at AB, I'm looking at the drawing, I'm going down 2 over 5. So negative 2 over 5 is my answer. If I look at BC, let's see, BC, I'm going up 2 over 1. CD, up to left 1. And DA, I'm going to say AD, rise of 2, run of 5, positive. Okay, now let's do the image slopes. That would be AB prime. So these are the primes. So this first one is like an AB prime. Let's look at it. AB prime, I have a rise of 5, a run of 2. BC. So it's B prime C, rise of 1, run of negative 2. CD, so C prime, D prime, rise of 1, run of 2. Rise of 1, run of 2. And DA, so D prime A is a rise of 5, a run of -2. A rise of 5, a run of -2. Okay, do you see any patterns here? Maybe opposite sign and reciprocal. Reciprocal. Yep, I've never liked spelling that word. So between the image slope and the original slope, opposite reciprocal, right? Let's do this product. -2/5 times 5/2. Cancel, 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 -1. 2 times -1/2. So 2/1. Cancel, cancel, -1. Do you see a pattern here? -2/1 times +1/2. And 2/5 times -5 halves. Cancel, cancel, -1. The product is -1 for all of them. So that's something we actually know about perpendicular lines. The slope of each line is opposite reciprocal of each other. And the product of perpendicular slopes is -1. Pretty cool, if I say so myself. Question 2 says the image of the warm-up is a 90-degree rotation of the original figure. So each line in the original figure is a perpendicular to the corresponding line in the image. Use your slope calculations to make a conjecture about slopes of perpendicular lines. And as usual, Miss Carly gets ahead of herself, doesn't read the whole problem before she starts explaining random things. Good job. Prove it. So the student task statement says, let's prove our conjecture about slopes of perpendicular lines for the cases where the lines pass through the origin. Those are the easiest cases. So find the slope of a line passing through point AB and the origin. Assume the line is not horizontal or vertical. Suppose the line is rotated using the transformation xy goes to -xy. I guess this can continue down. No, we're not going to do that. So let's do that in red. That means if I'm AB, it's going to go -B, A. A looked to be a little bit further. So this one is -B, comma, A. Right? So find the coordinates of the images of the points A, B, and the origin. So if I have the slope of this line, it's going to be rise over run. So that is B over A. And then if I have the slope of this line, it's going to be rise over run. So that's going to be A over -B. How does the original line relate to the image? It looks like they are opposite signs and reciprocal slopes. Okay, if you guys don't remember what reciprocal means, you're just flipping the fraction. It's A over B goes to B over A. And the opposite sign means if it was negative before, it goes to positive. If it was positive before, it goes to negative. I can't say negative reciprocal. I say opposite sign reciprocal because we're just flipping the sign of it, right? What I'd also like to point out is this value doesn't change. So if we're actually calculating slopes, it's going to be change in y over change in x. So b minus 0 over a minus 0 equals b over a. And if we're actually calculating this slope, change in y over change in x, so 0 minus a, well, let's not do that, sorry. A minus 0, let's be consistent, over negative b minus 0. And that gives us negative a over b. All right, so we found the slopes of everything. Compare your slopes. What did you just prove? We proved the opposite reciprocal thing that we proved actually in the last slide. It's all good. And here we see again just the drawings that we made with actual lines and everything. So here we're not drawing lines through the origin though. Let's go ahead and practice. We're going to do the yellow slope and the green slope. So let's do the slope of the yellow line. I'm just going to pick 2 points. I actually can't read sorry. Yellow line. So let's pick 2 points that we can actually read. I'm going to do, this is 0, negative 2 and 2, 2. So change in y over change in x. So 2 minus a negative 2 over 2 minus 0. That's going to give us 4 over 2. That has a slope of 2. Now the green line. I can pick this point and let's do that point. So this is 4, 0 and negative 2, 3. 4, 0, yep. So change in y over change in x, 0 minus 3, change in y over change in x, over 4 minus a negative 2. So here we have negative 3 over 6, which is negative 1/2. And that can be a 2 over 1. So we see our 2 slopes are opposite signs and flip the fraction. Okay, something we need to make sure we know how to do is how to write an equation to the line perpendicular to this one. So the slope for this given line is rise of 1, run of 1, 2, 3, 4. So I would like to, rise of 1, run of 4. I would like to get an equation for a line perpendicular to that one through point, let's do negative 9, 3. Okay, as practice. So we know the slope of our perpendicular. Actually, what I usually do is I want my perpendicular slope. So I do an m sub perpendicular sign. That's going to be negative 4. The equation we've been using is y minus y equals m x minus x. So let's do it. Y minus 3 equals m x minus a negative 9. Simplify that. Y minus 3 equals 4, negative 4, x plus 9. And we can leave it just like that. Remember, this is called the point slope form. Cool. I'm going to draw that line really quick. So I want it to start at negative 9, 3. Oh, negative 9 isn't on here. Why did I pick that point? Okay, there's 8 and there's 9. Oh, sorry. Negative 9 is the x value. So 7, 8, 9, positive 3, 1, 2, 3, with a slope of negative 4. So my rise is going to be 1, down 4. 1, 2, 3, 4. A run of positive 1. That's terrible. Okay, that should be perpendicular. Okay, fail on my part. Sorry. Good job today.